What is a network topology?
Means connection of a nodes. How are network connected to each other?
Graphical diagram means a topology is just going to display how your network devices are connected to each other, right? Or simply I can say graphical representation of your network. It displays how the nodes are connected. How many type of topologies are there? Star, hybrid, mesh, bus, then anything else? Is there any tree topology? It is okay. Star, ring, hybrid, mesh, bus, tree. So which of these topologies are being used right now?
Star.
Star. Is it only star topology?
Hybrid.
Hybrid also. What is hybrid?
Combination of multiple topology.
Multiple topology like star, bus, ring, right? Okay. This is also not being used because if bus topologies and these topologies are not being used, then hybrid and these are not used. Basically, right now, what all the topologies are being used? Only star and mesh. Okay, star and mesh. These are being used. Okay, tell me about mesh topology. What is a mesh topology? No.
In next topology, reverse connected by this positive A, B into C, and C into A, and something else.
That is a ring topology. If A is connected to B, B connected to C. Okay. So in your mesh topology, what happens? Whatever nodes are there, all the nodes are interconnected to each other. Like if 5 PCs are there, PC 1, 2, 3, 4, 5. So PC1 will connect to all 5. PC2 will connect to all 5. PC3 will connect to all 5. Like this, each and every system is connected to each and every other system. Okay. So if you want to define mesh topology, you can say that in case of mesh topology, every node is connected to all other nodes. Okay. Every node is connected to all other nodes. Okay, let's take an example for the mesh topology. For example, let's consider I'm taking here 5 nodes. Okay, like this, these are the 5 nodes. PC1, PC2, PC3, PC4, and PC5. Okay, now PC1 has to be connected to all the other nodes, right? So let's say, for example, I'll connect PC1, connected to PC2, connected to PC3, also connected to PC4, and connected to PC5. PC1 is connected to everyone. Okay, now PC2. PC2 is connected to already connected to PC1, right? Is it connected to PC3? No. Connected here. Connected. Now connected to PC4 also. And also connected to PC5. PC2 also connected to everyone. What about PC3? Where it is connected? PC1 and 2 already connected. Need to connect PC4 and PC5. Okay. Connected to PC4 and connected to PC5. Done. What about PC4? Already connected to 1, 2, and 3. Need to connect it to 5. Plus connect. Now all nodes are connected to every other node. Correct? Okay. Now tell me how many cables we required here. In this case, if I want to see number of cables. 5 cables? How? How come 5 cables? Count the number of cables we have used here. 10 cables. See, 4 black, 3 red, 7, 2 green, 9, and 1 blue, 10. Total 10 cables required. For how many nodes? 5 nodes, 10 cables. Okay. What if I connect 6 nodes here? How many cables will be required? 12. No. 12 will not be required. Okay. See, this time I'm going to connect 1, 2, 3, 4, 5, and 6. Let's say this is PC1, 2, 3, 4, 5, and 6. Connect 1 to everyone. 1, 2, 3, 4, 5. Correct? Then 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. So for IC will just see here number of node 5. Correct? So number of cables 10. If I increase only one node, how many extra cables? 5 extra cables, right? So number of cables 15. So what if I use 10 nodes? Need to make the diagram and see, right? No, no need to see. See, there's a formula. What's the formula? If you want to calculate number of cables in case of mesh topology, that you can calculate using n into n minus 1 divided by 2. Okay. And in this particular formula, where n equals to number of nodes. Now let's calculate. According to this, if we calculate, I have number of nodes is 5. So 5 into 5 minus 1 by 2. Right? 5 multiply 4 by 2. 5 4 is 20. 20 by 2, 10. If I go with 6 nodes, 6 into 6 minus 1 by 2. Right? That is 6 into 5 by 2. 6 5s are 30. This will become 15. So what if I use 10 nodes? That will be
45.
10 into 9 by 2. 45. Correct.
Yes.
What if I use 100?
100. 450.
450. Sure.
4500.
4500. 100 into 99 by 2.
450, sir.
450. 99 into 100, how much? See. See. I can simply say 50 multiply 99. So this is how much cables will be required just for 100 nodes. So in company, are there only 100 systems? There are big enterprises who are having thousands of systems. So you can imagine the number of cables that will be required. And if these many cables will be required to connect the PCs, you can imagine in the company, you'll see less PCs and more cables. Okay. So that's why this topology is not used inside the enterprise actually. Then where it is used? It is used on the internet to connect the internet routers. Okay. See, whenever you see internet diagram, how the diagram looks like? The diagram looks like this, where everything is interconnected. Okay. So that's why we see what is network we already discussed. Topology. Topology defines the structure, how all the components are interconnected to each other in the network. And two kinds of technologies or topologies are being used, mesh and star. So in case of mesh topology, what happens? A mesh topology is a network setup in which each computer and network device is interconnected with another.
So in mesh topology, all cables are connected in a single port, or we need more ports in?
How can we connect all these cables in one single port? Is it possible? Let's say this is a switch in one port. How many cables I can connect? At most one, right? So we need that many NIC cards also. Okay. So still not possible, right? So for this purpose, we do not use this topology in the enterprise networks. Okay. Okay. If I ask you, what is the disadvantage here? Of this topology? Number of cables, or I can say, okay, high number of cables. So if number of cables is high, obviously cost will be high. Implementation cost will be high. Any large networks. Is high. This is correct. Okay. What is the advantage here?
One node is down, we can reach another.
One node.
One piece is down, means we can reach with other.
If PC5 is down, how I can reach PC5?
We can reach to PC2 also, PC4 also, because it's all.
No. If my PC5 is down, so how I can reach PC5? Cannot reach. My PC5 is down. The benefit here is if one of the link goes down. Yeah, not the node. Here we have to say if one of the link goes down. Let's say consider your link between PC1 and PC5 goes down. So now this will not affect the connectivity. That's why our internet connectivity never goes down. Why? Because if one of the link goes down, let's say there was one cable coming to India, went down. Now what? I still have other options. I can go via PC2. I can go via PC3. I can go via PC4. Or I can go via like PC1, then PC2, then PC3, then like this. Means multiple possibilities are there. So even if a link goes down here, we still have the connectivity. And that's how our internet is running. Right? If one cable, okay, these are not the scenario that the cables never break. Okay. Or whenever they are going under maintenance, that time also the communication is stopped. Right? So it never affects our internet connectivity. That is clear. Okay. So what will be the advantage? If a link goes down, we still have the connectivity. Okay. If a link goes down, connectivity is still there. Okay. This is clear. All right. Let's move on to the next topology. The next one is star. Now in mesh topology, we cannot use in the enterprise networks, so we can go with the star topology. Now what happens in case of star topology? If you want to define a star topology, you can say every node is connected to a central device. And that central device can be a router, can be a switch, can be a hub, can be a server, anything. Okay. And in most of the cases, we talk it like switch and hub. Okay. Like hub or switch. Okay. Now we'll draw the diagram for star topology. So let's say, for example, again, we have 5 nodes. Node 1. Two, 3, 4, and 5. This is again PC1, PC2, PC3, PC4, and PC5. Now they have to be connected to a central device. Let's say your central device here will use a switch. This is a switch. Now what will happen? Every node will connect to the central device. Let's connect. All these things are interconnected to each other. Okay. Now looking at this topology, if we discuss number of cables, they are less compared to the mesh topology. So if number of cables is less, how about the complexity of network? Here one more point you can write. Here complexity of network is high. The network is complex in case of mesh topology. Complexity is high. Okay. Okay, if we discuss here number of cables, they will be less, means as many nodes you have, that many cables you require. So we do not need to go with so many cables. If you have 100 nodes, only 100 cables are required. Okay. Okay. So if I discuss about the advantage of this one. So what is the advantage here?
Less number of cables.
Less number of cables. Okay. Less number of cables. So obviously less cost. What about the complexity? Less. Less complexity. Okay. What about the disadvantage?
Finally goes down, you can communicate.
That particular node will lose communication. Okay. So this thing you can call it as a single point of failure. If a link goes down, if the link between PC5 and the switch goes down, now no node can connect to the PC5. PC5 will lose entire connectivity. Okay. So here we have single point of failure. This is clear. Okay. So in case of mesh topology, that topology setup allows for most transmission to be distributed even if the one of the link goes down. This is the mesh. But in case of star, what will happen? Star topology is one of the most common network setups. In this configuration, every node connects to a central device, maybe a hub, switch, or computer. The central network device acts as a server. Why the central device will act as a server? And this remaining, they will act as a client. See, who is a server?
Server will make it order.
Hmm?
The server will make it order.
Yeah, but what is a server?
Provide service.
To provide service. The one who serves. Same thing. The one who drives is the driver. The one who routes the traffic is a router. Similarly, the one who serves, provides some sort of service, that is a server. So what kind of service your switch is providing here? Information. Still you can see if PC5 wants to communicate with PC1. So PC5 will just deliver the information to switch. Now switch is responsible for routing this traffic or sending this traffic to PC1. And when the reply is coming, again PC1 will give the reply to switch only. And the switch is responsible to deliver that reply to PC5. Right? Kind of you can say postal service. We will give the letter to the postal service, they will deliver it. If the response is coming, it will come back to the postal service and they will deliver it to us. So they are providing the service. Similarly, your switch is also providing you the service. So that's why in between your switch will act as a server, and remaining all the clients, all the nodes which are connected to the switch, they will act as a client. This thing is clear? Okay. So here the central device act as a server and the peripheral devices act as a clients.